Okay. So, so we did this, and today we want to talk about something called work function. And work function is basically defined as the minimum amount of energy required by incident electromagnetic radiation to a surface to release. Uh, in fact, let's write a better word, to remove electrons from the metal. Okay. Now the symbol of work function is phi, like that, and the SI unit, because it's the energy, right? So it has to be joules only. So do write that, please. I'll just get me some water, and then I'll be back in 1 minute. Okay, let's see then. So then, after work function, now this is everything like you need to know about photoelectric effect. But photoelectric effect basically was not only the theory that was basically given, there was one more theory that was basically contradictory to it. And that theory is called wave theory. And sometimes he's going to ask you about the differences. So, wave theory basically suggests that electrons emitted from any source, electrons can be, in fact, let's write, electrons can be emitted from any source as long as light is incident onto it. So it doesn't say that okay, you need UV or something like that. Any light can do that. And it says the light has a continuous nature of energy. So it is exactly the opposite of what that is. In photoelectric effect, we say right because it has quantums. It says it's not. It's just constant energy that's being supplied. So it says which is accumulated by electrons till they have enough energy to release. So this is what wave theory is. So in photoelectric effect, the biggest difference is they say that you cannot have like more like sharing of energy if a particular size photon which basically has enough energy to overcome the work function stuff, you can get the electrons released. But wave theory says the electrons can accumulate from the source, and then it can do. So that's the major differences between them, and they will always ask you this, so you should write this now. Now I want to show you something. I'm going to wait for that.
So can you repeat the difference between
Yes,
them?
yes. So, Gatika, I just want to tell you that in photoelectric effect, right, or Einstein's theory of quantas, basically the quantum theory says that light is made up of particles called photons. Do you understand this? And it does not have a continuous nature, it has a particulate nature, which means that particles are moving, not like it's not like energy as a continuous chain. Do you understand?
Yes, sir.
Then the other thing is that it says the relationship between a photon and an electron is 1 to 1, which means it, an electron can only absorb like one photon at one time. Also, one photon cannot be shared by many electrons, or one photon basically, and one electron cannot just, have like many photons absorbed at one time. Do you understand this? So there's only 1 to 1. Like for one photon, there's one electron. Understood?
Yes, sir.
Now, wave theory says that it can do that. Like because energy is continuous, so it can keep on gathering the energy, and when the electron has enough energy, it can release. So, according to wave theory, any type of light can do that. But quantum theory says it cannot, because only when a certain amount of energy is there, which basically is greater than the work function means the minimum energy that is required for the electrons to release. If a photon has enough energy, which is more than work function, only then electrons can release. Do you understand? They cannot accumulate over time. Understood?
Sir, what have you written after continuous?
Nature of energy.
Okay, sir.
Any
So isn't the symbol for work function same as gravitational potential?
work function? It's phi. Gravity. Yeah,
What
yeah,
is
it's the same.
gravitational
Yeah, yeah, it's
potential?
same. In physics, many symbols are like used for many other quantities, so it's fine. Gatika, we could not invent so many symbols. That's why. So
No,
it's
sir,
okay.
I meant to ask how do we distinguish between them?
When they say it's work function, it's work function. And gravitational potential is basically in joules per kg, and this is in joules. Okay? So by the units. So Einstein's equation, we're going to verify that. And this experiment is very, very important. So, well, if you want to draw it, that's fine. If you don't want to draw it, that's also fine. I've done it for you. I'll share the notes with you, so that's all right. So what you see here is a photocell. Photocell zoomed up version looks like this. So there's a zinc plate, there's a copper rod, and the zinc plate is designed such a way that when some light of frequency I, that's the incident frequency, is shown onto the zinc plate, the electrons which are released, they are targeted towards the copper rod. Do you understand this? Now the funny thing is that as the light is incident, electrons will hit copper, and the electrons will try to move from the copper end towards this way, like the yellow current. Do you see? Okay. Because there is a potential, right, across them, so that's why that's happening. But in reality, if you look at this part, the electrons are entering from the side which is connected to the negative terminal of the battery. Can you see? So actually, the battery is supplying the current in the green direction, such to oppose the current that is coming from the photoelectric effect. Do you understand? Right? Now, so what we do is we keep on increasing the potential of the battery, and at certain potential, which is called stopping voltage, the current here in the ammeter becomes zero, which means that we have created so much repulsion at the copper rod that none of the electrons can now enter it. Do you understand this? Okay. So this is how we're going to do something about it. So just look at it. If you're confused about anything, please let me know before I start writing about it.
Can you repeat?
Yes. So you see, in a simple way, the light when it shines on the zinc plate, it releases electrons, right? It releases electrons towards the copper and a current like this goes. Do you see, Suman? Is that clear? And Rafi?
Yes, sir.
Okay, Rafi, you asked, right? Okay, sorry. Now, if you look at it, the current basically goes from the zinc plate and it is entering the copper rod in the yellow path, right? Do you agree?
Yeah.
Okay. So, then if you look at the battery, you see the battery here is connected in the opposite direction. Like the negative current is entering in the yellow direction, and also the negative terminal is there. So, negative terminal will try to oppose the flow of current through the photoelectric effect. Do you understand? Now, this supply is a variable one, so we keep on changing. We change the potential such that we want the amount of current flowing, like we want the amount of current flowing this way and this way to be equal. Do you understand? If both of the currents are equal, then what will happen? The current will stop flowing, and when do we know the current stops flowing? Is when we see in the microammeter that it shows a zero reading. When the current stops flowing, we call this as stopping voltage that we provided. Do you understand now?
What did we do it in? I joined a bit late.
What are we doing? Sorry.
What did we do before this?
We just learned about wave theory and work function. That's it. Okay, Rafi? All right. Now, so let's move on. I'll write it down so you guys can understand it by writing, which is very important. So, first of all, we say that light goes and hits the surface, or in fact, I'll write the curved surface, and so the electrons are ejected from the metal surface. Okay, then what you're going to do, the metal surface is curved skillfully so when electrons are released, they are targeted at purposely placed anode collector. Anode collector can be like, this is the copper ore, right? In this one, in the middle, like that. Okay. Right. Now, the next thing is the ammeter reading should always be 0. And how to keep that 0? We use a regulated variable power supply. And thus are able to change amount of work done by battery such that we stop the fastest moving electrons and ensure current is 0, right? So we want to stop it. Now, this is the reason, because the electrons have kinetic energy. They've just been released and they have a lot of kinetic energy. So what you're going to do is, we should understand that the work done by the battery, because it's put against it, against the flow, so the work done by the battery has to be equal to the maximum kinetic energy of fast moving electrons. And that's something we need to remember. Okay, please write this down and let me know if you have any questions. In this chapter, there's so much to write, Okay, now, the next thing you should basically write is about the stopping voltage, and this definition is, it comes all the time. So the stopping voltage means it is the minimum voltage required by regulated power supply to stop fastest moving electrons ejected during photo photoelectric emission in a photo cell in the completing circuit. So you need to just remember this, please. Very important definition for all of us.
Sir, what is the purpose of keeping the current zero and stopping the electrons?
I'll tell you in a bit. You just write it down. Okay. Now this is a very good question. Why do we want to stop them? This I need to explain it to you with some mathematics. Okay. So basically, this was Gatika, the photocell. This was the anode collector. Where the electron was released, the fastest moving electron would have the greatest kinetic energy, right? You agree?
Yes, sir.
And the the work that we're doing by the batteries negative terminals from here is such that we want to stop this. So it means that if I write some math behind this, so what I basically want is I want the work done by the battery to completely overcome the maximum kinetic energy of electrons. Do you understand this? Now, how do we get maximum kinetic energy anyway? We get it by, now battery is basically giving us like voltage, which is the stopping voltage, times the charge, which is charge is E. So let me write the formula first, VQ, so you guys are not confused. So this is the energy of incident photon minus the energy of the work function. So let me just tell you what's happening here. So this is basically the stopping voltage here is Vs and the charge on electron is equal to E. The incident energy, this energy which the photon has, is equal to Planck constant times the frequency of incident wave. Do you understand this? And the work function would be basically Planck constant and the threshold frequency, that is the minimum frequency the metal requires to release electrons, right? So I just want to tell you this is the work function if you don't know yet. Okay. So now if I see this, this becomes, E times Vs, this is H Fi minus H F naught. I can actually compare this with y equals to mx plus c. Do you know this equation from math? So, which means if I draw the curve of this, now this curve is very, very important because it will basically define your understanding of this. So the curve has to be on two ways like this. On this side, we have the work done in EV, right? EV is the electron volts, you know this. This is 0 electron volt, this is minus EV. And here you have the incident frequency, like that, of the wave, whatever wave is coming. So you see that it has a negative intercept. Negative intercept basically starts from somewhere here. So let's say this is minus HF naught, right? That's the negative intercept. And then the line basically has to be a straight line with an intercept, of course. And this point where you see this is where you do not have any kinetic energy. It means this is the minimum energy or the minimum frequency that is needed for the metal to allow electrons to release, which means this point got to be the threshold frequency. So this is how from the graph we can find the threshold frequency, and for the rest of it, if the frequency is higher, the higher the frequency of the wave is going to be, the greater the kinetic energy of the electrons are going to be. And then of course the battery needs to do more work to stop them. Do you understand my whole idea behind this? It's not my idea, it's Einstein's idea, but that's how I want to tell you. So basically what I'm trying to explain this to you like this, oh no, is that from this point onwards, like this point onwards, if I go forward, it's basically the photoelectric emission. Is it clear? Now, I want to tell you one more thing. And if you look at the gradient, so if you take the gradient of this line, like make a triangle, so you should remember that the gradient of this line will always give you Max Planck constant, okay? So that's one thing that I want to tell you, and that's how this whole thing came up. Okay. Okay. Any questions now? Ramin and who's the new girl? Nida. Nadia.
No questions, sir.
Okay. Fine. All right. In 10 minutes, I think you guys should be able to join again. But let's see if we can, finish the part that I want. Okay. Yeah. Okay, so the last thing we're going to write today is basically, I just want to start this off and then we can, continue next time. So there's another scientist, Neil Bohr, and we got to write its experiment. It's a very short one, but that's just the basis of everything that we're going to do forward. So Neil Bohr experiment basically includes sort of a tube light Tube light is basically sort of, a tube filled with gas, and then of course it is connected with switch and a supply. So basically you just need to write that he observed that energy, in fact every vapor or gas has a unique pattern. So he concluded that every metal, every material, in fact, every material used inside the gas tube gave a spectral pattern signature to the material. Spectral pattern is basically like the amount of colors, different colors it gives. So we're gonna show that. I'm gonna show that to you soon. Okay. So he proposed that energy is transferred only in certain well defined quantities. That's very important. We'll discuss it later on. So electrons move around orbit, but only in prescribed orbit. They just don't do it randomly, okay? So we need to be very, very careful about that. Redefining some of your chemistry as well. And this is the most important point that I'm going to write now. When jumping from one orbit to another with lower energy, a light quantum is emitted. The final thing that we're going to write, that this theory explained why atoms emitted light with fixed wavelengths. And if he wasn't there, right, you would never be able to know, you would not have been able to know what type of gases, what type of materials are in different stars and different places in celestial bodies. So yeah, he's a very important person. Okay. Okay. Just a second, please. All right. If you have any questions, please let me know right now. Okay.
So can you please explain this again?
Gatika, there's a lot to explain for this. I just want to tell you 2-3 things again. So according to him, okay, when, like, if there's a gas inside a tube and you supply energy to it, so how can you supply energy really? You can supply energy in 3 ways basically. You can heat them up, you can supply electrical energy, or you can supply light energy. Do you understand what I'm saying?
Yes, sir.
Okay. So according to him, electrons basically keep on revolving around in an atom in very they, I mean in their prescribed orbits. Do you understand? If an electron somehow gathers energy, it can shift its orbits, like it can go to an orbit that is of a higher energy. Do you understand? But the electron cannot stay there for very long, so it comes back to its original orbit. But when it's coming back, energy can neither be destroyed nor created, right? That's what we've learned. So when it goes to a higher orbit, an orbit of higher energy, and when it returns back, the energy that it has amassed, it releases a photon of that same amount of energy. Do you understand?
So didn't we write lower energy in the point?
Yes, when jumping from one orbit to another with lower energy. Do you understand? Like if an electron is at higher energy, you have heated it up and it goes to higher energy, right? When it returns back to an orbit with a lower energy, so that energy that it had amassed previously, what would it do with that energy? It is going to release a photon of equivalent energy that it has lost now. Do you understand?
Yes, sir.
And what he's trying to say is that every gas that I put in this chamber that you see right now gives me a different spectral pattern that is very unique to the gas. So it means that every gas, every material, all right, it has a very unique structure that is only a signature to it, and that's how we can categorize them. Do you understand?
Yes, sir.
So what I'm trying to tell you is that even when light comes from sun, right? They talk about, okay, sun is made up of this glass of flan gas, of flan gas. You know, talk about that. So how do they know that which gas or what type of materials are there in the sun? You can't physically go there, right? We know it because of this theory, and we're going to learn it soon. Okay, is it clear?
Yes, sir.
Yeah, so it's something very new for you people. It's something you're doing it for the first time. So I would appreciate that even if you have a slightest doubt in it, please do ask me and I will help you with all my knowledge. All right, is it clear, everybody? If you have any other questions, please let me know. Otherwise, we have to now close the meeting.